Okay, today we're going to be talking about arithmetic series. So this is about arithmetic series. And if you don't know what an arithmetic sequence is, make sure you go back and watch the video on sequences, because this video assumes that you know what an arithmetic sequence is. Okay, so arithmetic series. We're going to start with an arithmetic sequence. Let's go with, we'll just count the odd numbers. So we got 1, 3, 5, 7, 9, 11, and we'll stop there. Okay, so our pattern is that we're going to add 2 every time, starting with 1. So we have a difference of 2, because it's plus 2 every single time. And the difference between a sequence and a series is the series is going to stop. And here I have a set number of numbers, and the big difference is we want to add them up. Okay, so I want to add up all these numbers, and I have 1, 2, 3, 4, 5, 6. So I want to add up the first 6 numbers of this arithmetic sequence. And what you're going to have is this big fancy letter S, and then we often put an n there. So in this case, I'm looking for S sub 6. That's the specific case for this n. And this S is standing for sum. So a series is a sum, a summation, and we want to add up all the numbers. So if I want the sum of all this, all I'm going to simply do is add up all the numbers. So we could add them up, and there's going to be some easier and harder ways to do it, and it doesn't really matter how you do it, but you could add up all these numbers. So for example, 9 and 11 is 20, 7 and 3 is 10, so that's 30, 5 and 1 is 6, so the sum of these numbers is going to be 36. So when you have a finite set and it's really small, you can simply add them up, grab a calculator if you need to, but all you're going to do is add them up. What do you do when you have a large set? And that's what we're going to look at. So let's look at, for example, let's go ahead and look at the first 100 numbers. So 1, 2, 3, 4, etc. And we want to go all the way to 100. And we want to add these up. I want a summation for the first 100 numbers. Okay? So let's first look at the first 10 numbers, because this is going to be helpful for us. So I'm going to go ahead and write out the first 10 numbers. And what we want to do is come up with a formula that's going to allow us to add these numbers up, where we don't actually have to add up every single number. And the way we do it is we're going to put them in pairs. So we're going to add up the first and the last number, and that adds up to 11. We're going to add up these 2 numbers, and that adds up to 11. And we're going to keep going back and forth until we run out of numbers. And what we're going to end up doing is saying, you know what, I don't actually have to add up all these numbers. All I know is that there are 1, 2, 3, 4, 5, 11. So if I go 11 and multiply it by 5, the answer should be 55. I don't have to add them up individually, because I know there are 5 sets of 11. And that's what we're going to do in general. So how did we come up with this pattern so that we could only add up certain ones? Well, first off, I need to know the first number. And we denote the first number as a sub 1. I also need to know the last number in the pattern, which is a sub n. And then what did I do? I actually added them up. So our summation is going to be the first number, a sub 1, plus the last number, a sub n. That's a really big important part of it. But we're not done with that. We multiplied it by 5. And the question is where did the 5 come from? Well, the 5 comes from is pairs of numbers. So if I had all the numbers, there would be 10. So in this case, n is going to be 10. But I only want half of them because I'm pairing them up. So what we're going to do is we're going to multiply this by n and then divide it by 2, which means that I need half of my actual numbers n. So if there's 100 numbers, I want 50 of them, and that's what this n divided by 2 is for. So what we're really doing is we're going to add up the first and last term, multiply it by half of the numbers I have, and that should be our summation. So this is our formula for summation. So let's go back to the first 100 numbers. We want to know the first 100 numbers, how much they add up to. Now we could actually get a calculator and add up all 100 numbers, or we can simply know the first and last number. So our summation is going to be our 100 numbers, the first number, which is 1, the last number, which is 100, add them up, and we have to divide that by 2. Now here order of operations applies. You're welcome to use a calculator. If you're going to not, make sure you follow order of operations, but 1 plus 100 is 101. And I'm going to do a little trick. I'm going to go ahead and divide this by 2, so that's 50. And I need to multiply 50 by 101, and you get the number 50/50. So 5050 is how many numbers, if you took up the first 100 numbers, you added them up, you're going to get the number 5050. So that's an easy way to do it where you don't actually have to add up every single number. There's a couple other things I need to show you. It's about notation. So I want to show you a little bit of notation up here. But in general, you've got the basics of what arithmetic series is. You need to add them up. But you also will see this notation. This is called sigma notation. It has some key parts. Anytime you see this big, fancy, it's a Greek letter sigma, you will see something below here, and it's often a letter. It doesn't really matter what letter it is. I'm going to use the letter I today. And that just tells you what variable you're going to see over here in a minute. And then we have to tell you where to start. Often we start at 1, but there's no rule you have to start at 1. But often it's at 1. And then up here we have to tell you where to stop. So in this case I'm going to put 100. Okay, so this is saying that starting with number 1, ending with the 100th term, we want to add up all those terms, which is what we were just doing. And then I have need a rule over here. So let's say that our rule is, let's just go with I. Okay, so what we're going to do is we're going to replace the number with I, and that's going to be our first number. So this says starting with 1, replace I with whatever this is. So we're going to replace it with the number 1, and then we're going to do the same thing with the second one. The second one is going to be 2, and then the third one is going to be 3, and we're going to keep doing this all the way until the last term, and the last term is going to be 100. Well, this is the one we just did, which is why I picked I over here. Okay, if it's something else instead, like 2i plus 3, then you're going to plug in 1 in here, and you get 2 times 1 is 2 plus 3, so our first number would have been 5. The last number, because often we just need the first and last numbers, we're going to plug in 100, so that'd be 2 times 100 is 200 plus 3 is 203. Okay, so it's whatever is right here as a formula, you're going to plug in the first and the last number. Okay, remember, to use this formula, you need n, a sub 1, and a sub n. A sub 1 is you plug in the first number. A sub n is you plug in the last number. So the question is what is n? Well, n is always defined as the top minus the bottom plus 1. And the reason plus 1 is when you subtract these two numbers, you end up 1 short every single time. So you have to add 1 back in here. So we're going to do 100 minus 1 plus 1. And minus 1 plus 1 is 0, so it's really just 100. So when I is 1, this number is also n, and that's a special case. It only works if the bottom number here is 1, so make sure that you look before you decide that the top number is n, is this bottom number has to be 1. If it's anything else, you have to do top minus bottom plus 1. Okay, and don't forget the plus 1. Top minus bottom plus 1. But in this case, it is 100. So we needed 3 things. You need a sub 1, a sub n, which you can get by plugging these two numbers in for whatever the formula is here. And then you need n, which is either going to be top minus bottom plus 1, or simply the top when the bottom is already 1. Okay, once you have those 3 things, you plug it in this formula, and we do it just like we did it before. The last thing that I need to show you, and I'll erase a little bit over here so we have some room, is you only need 3 of these 4. It does not have to be these 3. If I give you any 3 of these 4, you should be able to find the other ones. And the most popular one is to figure out what n is. So let's say that I tell you that s sub n is going to be 50/50. I tell you that a sub 1 is going to be 1. And I tell you that a sub n is going to be 100. And I need to figure out what n is. You should be able to solve this using algebra skills. We're going to just plug these numbers in the formula. So the formula says that s sub n is 50/50. I don't know what n is, so it's going to stay n. I know the first term is 1. I know the last term is 101. Or excuse me, 100. I was jumping ahead there. And we're going to divide it by 2. Okay, order of operations says I go ahead and add this up first. So we get 50/50 is going to be n times 101 divided by 2. And then you could divide 101 and then move it over here. I'm going to go ahead and multiply both sides by 2. So that gives you 0, that's going to be a 10, and that's another 10. So 10, 100. And then we're going to end up having 100n left on this side because we multiplied both sides by 2. And then lastly, we're going to divide by 101. And when we do that to both sides, it says that n is 100, which of course it is because that's the problem we did over here, which is why I picked it. We knew n was 100. But you should be able, no matter what I give you, that if I give you 3 of these 4, s sub n and a sub 1, a sub n, you should be able to solve for the other missing variable. It does not matter the order. Most typically, it'll be like this example over here, where we give you n, a sub 1, and a sub n, you're finding s sub n. But it doesn't have to be that way. It could be any of the above. If you have any questions on arithmetic series, please make sure you ask.